A powerful early season storm is now evolving across the United States, one that will test the atmosphere's full dynamic range. Over the next several days, this system will bring everything from accumulating snow and blustery winds across the Great Lakes and to the Midwest, to an Arctic surge of cold air diving all the way to the Gulf Coast and even northern Florida. What makes this event extraordinary is its timing. The pattern developing overhead would look more at home in late January than in early November. So today, we'll explore not only what is happening, but why, examining the jet stream dynamics, temperature structure, and the energy transport that make this outbreak so unusual. To understand the cold, we must first look at what's happening right now across the nation. As of this afternoon, a departing coastal system is pulling away from the mid-Atlantic, leaving scattered rain along the eastern seaboard, and a few lingering gusts as well. Yesterday, the same disturbance sparked isolated severe weather in Kentucky and Tennessee, producing brief tornado signatures and locally heavy rain, but overall it was a low-end event. The attention now shifts to the northern plains, where a new cyclone is taking shape over the Dakotas and Montana. This feature sits along a strong temperature gradient, the boundary between milder Pacific air and much colder continental polar air spilling down from Canada. As that gradient tightens, the pressure falls, a surface low begins to deepen. Embedded within the system's leading wave is an impressive mid-level vorticity maximum, essentially a spin in the atmosphere which acts as the seed for cyclogenesis. We can already see a comma-shaped cloud pattern developing on visible satellite imagery, the classic signature of an organizing winter storm. Here's the heart of our pattern, a broad, negatively tilted trough plunging through the western United States and into the plains at roughly 500 millibars, or about 6 kilometers above sea level. These height contours reveal the steering flow of our mid-latitude westerlies, where they bend sharply south. Cold air usually follows. Within this trough sits a compact shortwave over the Dakotas. As the shortwave digs southeastward, strong differential vorticity advection, where rotation increases downstream, triggers rising motion, cloud development, and surface cyclogenesis. At the uppermost level, around 300 millibars, a powerful jet streak, winds exceeding 140 knots, dives out of western Canada. Notice the entrance and exit regions of that jet. The left exit region sits directly above the forming surface low, enhancing upward motion. This coupling of upper and lower level features is what transform a modest disturbance into a dynamic storm. The result will be deep southward transport of cold, dense air and an equally strong northward surge of warm, moist air ahead of the front, setting the stage for widespread precipitation and eventual snow. Now that we've examined the upper air driver, let's descend into the mid-levels and explore how the Arctic air mass is being constructed. At 850 millibars, roughly 1 mile above the surface, we see the thermal backbone of this entire event. Look at the deep blues cascading south from Alberta through the Great Plains. That's a true Arctic air mass. Temperatures 15 to 25 degrees Fahrenheit below average. This cold air is dense and shallow. It hugs the ground and moves rapidly, guided by terrain and pressure gradients. As it spills southward beneath warmer air aloft, the atmosphere becomes strongly baroclinic, meaning temperatures and density change quickly with horizontal distance. Notice how the cold tongue reaches all the way to the Gulf Coast by Monday. At the same time, a ridge over the eastern Pacific deflects mild air northward into the west coast, creating a sharp contrast across the Rockies. This contrast is why the jet stream amplifies so dramatically. By Sunday night into Monday, that cold air will drive frontogenesis along a line from the Ohio Valley down through the lower Mississippi Valley. Lift generated along this boundary will convert moisture to snow in the cold sector and rain elsewhere. This is the moment when the storm transitions from a synoptic rain event to a winter weather event for millions. Next, we'll see how these cold temperatures translate to the surface, where records may fall, and daily life will feel the brunt of this Arctic surge. As the Arctic front plunges south and east, surface temperatures will crash in dramatic fashion. Within a 12-hour window, parts of the central plains will tumble more than 12 degrees Fahrenheit below normal. Parts of the northern plains will see temperatures up to 21 degrees below normal. By late Sunday night, the well below average temperatures reach Kansas City and St. Louis. By Monday morning, it slices through Dallas, Shreveport, and Jackson, Mississippi, regions that rarely experience their first freeze before mid-November. Some areas will be up to 25 degrees below normal for this time of year. Tuesday morning, the cold air settles over the southeast, reaching deep into central and northern Florida. Widespread record lows are likely, in some cases shattering decades-old records from 1986 and 1991. Knoxville may drop to 24 degrees, Atlanta to 26 degrees, and Gainesville, Florida to 32 degrees, and even 31 degrees there for the first time since the Reagan administration. Even Orlando and Tampa could dip into the upper 30s as well. Also, Pittsburgh, Pennsylvania will be at 28 degrees, which is only 3 degrees colder than northern Florida. Tupelo, Mississippi will be at 28 degrees as well, and Myrtle Beach, South Carolina will be at 34 degrees. This air mass is exceptionally dense and dry. Dew points in the teens and 20s will allow for rapid radiational cooling at night. Agriculture and animal care become top priorities during such outbreaks. Protect tender vegetation, bring pets indoors, and ensure livestock have shelter. While short-lived, a hard freeze of this magnitude can damage citrus, berry, and nursery plants throughout the Deep South. With the cold securely in place, attention turns to its companion, snowfall, and how the atmosphere uses the Great Lakes as fuel for winter's first major display. Currently, bands of snow are developing across the Dakotas and Nebraska, spreading eastward into Iowa and southern Minnesota. Here, temperatures hover near freezing, so much of the precipitation will fall as a rain-snow mix, and a slushy coating on grassy surfaces is expected, but little impact on roads. As the low tracks east into the Great Lakes Sunday, a wraparound band of moisture meets the incoming Arctic air, changing rain to snow from Chicago northward into Wisconsin and Michigan. While the Windy City will experience dangerous travel conditions, they will see 6 inches of snow. Northern Illinois and southern Wisconsin could pick up to 2 inches of wet snow. Erie, Pennsylvania, and Cleveland, Ohio will see between 5 and 10 inches of snowfall, while Pittsburgh could see a coating to an inch on the grassy surfaces. Roadways should remain clear in the Pittsburgh area. Lake effect bands will be moving through the entire region during this time frame as well. Cold air streaming over lake waters still in the 40s creates intense instability in the lowest mile of the atmosphere. Clouds explode downwind of the lakes, narrow intense snow bands that can drop inches per hour. In far western Michigan and northwest Indiana, a persistent band off Lake Michigan may deliver 6 to 12 inches of fluffy snow, locally up to 18 inches if the band stalls. Further east, northeast Ohio into western New York will see similar amounts, particularly south of Buffalo and around Watertown. For central and southern Ohio, Kentucky, and Tennessee, expect mainly flurries or a dusting on elevated surfaces. Monday night through Tuesday, secondary bands develop over Lake Erie and Ontario as cold air persists. By Wednesday morning, snow depth maps will reveal distinct jackpot zones corresponding to those bands, the hallmark of lake effect snow events. Once the lakes settle and high pressure builds in, the snow machine will quiet down, but the cold will linger a bit longer than you might expect. By midweek, the primary low-pressure system lifts into eastern Canada, but its imprint remains. A broad trough still encompasses the eastern half of the United States, keeping temperatures below average from the Great Lakes to the Appalachian Mountains. High pressure establishes over the central U.S., creating clear skies and light winds that allow nighttime temperatures to remain chilly. And out west, a ridge of high pressure builds along the Pacific coast. This ridge funnels in warmer air northward into California and the Pacific Northwest, producing temperatures 10 to 15 degrees above average. Such a split pattern, ridge west and trough in the east, is common during transition months as the polar jet realigns for winter. And speaking of the next storm cycle, our eyes turn westward to the Pacific, where a new source of energy and moisture is taking shape. And then by the weekend, a series of Pacific storms will begin to tap into the subtropical moisture streams known as atmospheric rivers. These plumes of high precipitable water extend from near Hawaii toward the west coast. And these will be capable of delivering inches of rain and feet of mountain snow to California and the Pacific Northwest. While beneficial for water supply, they also pose flood risks and snow load hazards for high terrain. As that moisture crosses the Rockies, it may spawn out our next continental storm system around day 10 or so. Model ensembles hint at renewed baroclinic energy over the Central Plains, which is the birthplace of many classic winter storms. And whether that evolves into a snowmaker or a severe weather event will depend on how quickly the jet stream realigns. In summary, the coming week marks a textbook transition from autumn to winter. We will see a deep trough over the east bringing record-breaking cold and snow, a ridge building in the west promoting milder conditions there, and a potential reversal within 2 weeks as the Pacific pattern reloads. And you can see that there. You see that low pressure crossing the Rockies and then heading into the Pittsburgh area, and then another storm system comes in and goes up the coast. Could bring in some snow. We're going to have to watch that very carefully. Thank you for joining me in another weather update. Stay warm and stay informed, and take a moment to appreciate the beauty of this planet's living atmosphere. I'm Zachary Clark. Thank you for joining me for this forecast analysis. I'll continue to track this pattern as winter takes its first breath across America. If you're new to the channel and have found this information helpful, please consider subscribing to the channel and enable notifications so you don't miss a weather update. I'll see you in the next one.